AI RAN in the real world, what does success look like? It's great to have you all with us, and I really hope you enjoyed the session. And I'd also like to say a big thank you to our sponsors, Red Hat, who are partnering with us on this one and bring extensive expertise in AI RAN. In terms of the agenda for today, we will have 3 presentations actually. The first one will be from SDL Partners, and it will be followed by presentations from Red Hat and Ericsson. So stay tuned because there will be a lot of great insights shared. And then at the end of the webinar, we should have about 25 to 30 minutes for a panel discussion. And I have no doubt that it will be a great session, so stay tuned. But before we begin, just a quick bit of housekeeping, if we can go to the next slide to kind of make sure that everything goes smoothly. You should see a control panel on the right-hand side of your screen, which is marked by arrow number 1, and you can expand it or hide it using the orange arrow button at the top. Inside that panel, you'll find a questions box where you can type any questions or comments that you may have during the session, and then we'll try to go through as many of those as possible during the panel discussion, which will happen towards the end of the session as mentioned. And I can assure you that you won't be named in any way, so please feel free to ask whatever you want to ask and we'll do our best to answer it. But if we can't get to all of the questions, and sometimes we really can't because we receive so many, then we'll ensure to give you written answers and distribute those after the session. And we will also make the slides and the recording of the session available. In terms of logistics, all attendees are muted and in listen-only mode. So if you're having any problems with, for example, sound, I do suggest you try signing out and then back in, and hopefully that will sort it. Sometimes it does, but if it doesn't, then please let us know using the chat box and we will do our best to help you out. And you can also raise your hand using the hand button, which is marked by arrow 2 if you need to get our attention. And I think that's it in terms of housekeeping. So who do we have on? If we go on to the next slide, we have a fantastic lineup of speakers today representing perspectives from across the AI RAN ecosystem. So starting with my colleague Alice, who is a consultant at SDL Partners, and we'll kick things off with a presentation on how AI RAN can build on the principles of O-RAN. I'm Gabby, I'm one of the senior consultants at SDL Partners, and I'll be your host and moderator for today's session. We're also joined by Fatih Nar, who is a distinguished chief architect in the CTO office at Red Hat, and he will share insights from Red Hat's perspective. We also have Melike Errol Kantarci, who is a senior product manager for AI RAN at Ericsson, and she'll bring a presentation from the vendor's perspective. And last but absolutely not least, we have Kanika Atri, who is a senior director of telecoms marketing at NVIDIA, and she will bring NVIDIA's perspective on the topic to the panel. So without further ado, let's get started. Alice, over to you.
Thank you for the introduction, Gabby, and welcome to everyone in the audience. And to our lovely panelists and presenters as well. This webinar marks the 4th in our series on AI RAN. And nowadays, it seems that the words O-RAN and AI RAN are surfacing in similar industry conversations. And although the core concepts are different, the two are arguably interlinked. The industry has been pursuing O-RAN for a long time, namely since 2018, via the operator-led O-RAN Alliance. This has been working to standardize interfaces while also defining and commercializing the RAN Intelligent Controller, or RIC. So various R apps and X apps can be used to tame complexity and cost while adding capabilities that can be monetized. Some of the core key principles of O-RAN are openness, which implies ensuring open interfaces that allow different vendors, applications, and models to interact with the RAN in real time. And closely linked to this is disaggregation, which means the separation of hardware and software, creating dynamic flexibility. And another important principle is standardization and standards-based compliance. So, for example, ensuring standardized data formats, enabling consistent access to RAN insights. And finally, open governance is important too, as this will facilitate collaboration and transparency of market information to make sure the industry evolves through collaboration and coordination rather than proprietary vendor roadmaps. Now, with AI at the center of numerous industry discussions and operators and enterprises both looking to capitalize on this opportunity in different scenarios, industry discussion has turned to AI RAN, where artificial intelligence is embedded throughout the RAN in order to, again, tame complexity and cost while adding capabilities that can, in turn, be monetized. We at STL Partners therefore think that the principles of O-RAN will underpin successful AI RAN deployment and development, providing the architectural foundation that exposes the necessary data and interfaces for AI to be integrated effectively. AI RAN really represents the step built on top of the O-RAN foundation, and by leveraging this openness, it will allow operators to introduce advanced intelligence and automation into the RAN. These principles will help by reducing the risk of vendor concentration, enabling data portability across the ecosystem, which will ultimately make it easier to facilitate the embedding of AI. Looking at the impact that O-RAN principles might have on AI RAN demonstrates how O-RAN can both open up and reshape AI RAN deployments. The reality for the time being is likely to be AI RAN deployment without necessarily O-RAN principles, which you'll see on the left-hand side of the slide, given the array of existing RAN infrastructure built and operated without these principles. Nonetheless, we see a significant opportunity for AI RAN to transform the RAN into an open and collaborative ecosystem, enabling AI RAN to scale and deliver value. With O-RAN, openness enables seamless integration and communication between different pieces of equipment, rather than potential constraints around integration in a stack comprised of equipment from a single vendor. If operators abide by this O-RAN principle, this ensures that all parts are interoperable, so different equipment pieces can seamlessly communicate and integrate. Secondly, if we look at disaggregation, with O-RAN principles, when the stack is separated, you can therefore bring in best of breed vendors. So this could be radio vendors, RIC software, and AI engines, each focusing where they excel. And this is a very different world from where one vendor controls the entire stack and effectively sets the pace of AI innovation. So avoiding vendor lock-in really fosters healthy and dynamic competition and innovation as well, therefore accelerating progress overall. Standardization will also play a crucial role in enabling AI RAN to scale and deliver value. Bodies like the O-RAN Alliance alongside 3GPP are doing important work to define common interfaces and data models so that once an AI solution works in one network, it can be replicated across many without months of bespoke integration. This means that all parts are interoperable, which again makes the integration of different pieces of equipment much easier. Finally, open governance and transparency will be important too. So instead of a single vendor roadmap, you'll have operators, vendors, and new entrants shaping requirements together in industry forums. And this collaborative model will make it easier for AI RAN to evolve and ultimately to deliver more value to customers. Now, it is not just us at STL making the association between AI RAN and O-RAN. Telcos are thinking about this too. And the 5th edition of the heavy reading O-RAN operator survey identifies a strong link between AI RAN and O-RAN. But not everyone is putting these two technologies on a straight line continuum. The survey asked operators to look 5 years ahead and say how closely they expect AI RAN and O-RAN to be linked to their companies. Interestingly, 30% of respondents said AI RAN and O-RAN will be very closely linked. For this group, the view is basically that you need O-RAN to do AI RAN properly, and this chimes with wider industry analysis that sees O-RAN as really the way to bring multi-vendor innovation and AI deeper into the radio network. This figure actually rises to 47% when filtered for those respondents who expect to be in live O-RAN deployments by the end of 2025. So in other words, the pioneering group of O-RAN respondents identified in the survey are more likely to see a closer link to AI RAN than those who are more conservative on O-RAN deployment. This means that leaders in the O-RAN space are pursuing AI RAN opportunities in tandem with O-RAN opportunities and kind of setting the example by associating these two things. The largest respondent group, sitting at 36%, expect O-RAN and AI RAN to be closely linked. So they still see a strong role for O-RAN, but they also expect AI to be applied in more traditional architectures. So in practice, this might mean using O-RAN principles for new greenfield or high-value sites, while also adding AI-driven optimization to existing RAN infrastructure. We then have just under a third who think AI RAN will only be loosely linked to O-RAN. They still plan to use AI in both traditional and O-RAN environments, but they do not see a single strategy that necessarily knits these two things together. But they do see a role for AI in the RAN. And finally, only 5% said they had no interest at all in AI RAN, which means an overwhelming 95% are interested in pursuing AI RAN, whether this is in conjunction with O-RAN or without. Our thinking at STL is therefore in line with wider industry opinion. Although O-RAN and AI RAN are not formally interdependent, we feel that their relationship really matters. So beyond what operators say in surveys, we can also look at what they do in terms of industry alliances. And here the story is that AI RAN and O-RAN are already being treated as related conversations. If we start on the left-hand side of the slide, this is the AI RAN Alliance. So it's a very young organization, and it was launched in 2024 with 11 founding members. And its mission is to weave AI directly into the fabric of the RAN so that AI becomes a native design principle rather than bolt-on. In just over a year, it has grown to more than 100 members, bringing together a variety of players, including hyperscalers, AI chip companies, software vendors, network equipment providers, and some operators that all want to experiment with AI native RAN architectures. And on the right-hand side, we have the O-RAN Alliance. So this group was founded back in 2018 by 5 major operators and now has well over 200 member organizations worldwide. Its focus is on creating open, modular, disaggregated RAN architectures that are more intelligent and interoperable. Typical members here are more likely mobile operators and traditional RAN vendors. But the interesting part for us is the overlap in the middle. So a meaningful set of players sit in both of these circles. So companies like Ericsson, Nokia, Samsung, T-Mobile, SoftBank, and others are explicitly choosing to work on AI native RAN and on open disaggregated RAN together. This tells us that they do not see these as competing agendas. They see AI RAN as something that will ride on top of and benefit from the standardization work being done by the O-RAN Alliance. So this membership picture really complements the survey findings we looked at on the previous slides. It shows that for some of the most influential companies in this space, AI RAN and O-RAN strategies are already closely intertwined. To conclude, I think it's probably valuable to bring it back to what this actually means for operators evaluating their AI RAN opportunity. Here at STL, we have 3 key strategic recommendations. Firstly, we would encourage operators to adopt O-RAN principles. Aligning your architecture, interfaces, and governance with O-RAN thinking creates the foundations that we've been talking about and gives you the flexibility to place intelligence where it most makes sense. Without that groundwork, AI in the RAN will remain a collection of isolated pilots rather than something that can scale. Secondly, the formation of ecosystem partnerships is really important, and operators cannot do this alone. When you adopt O-RAN style principles, it becomes much easier to bring in partners that can plug those technical and operational gaps, because everyone can meet around standard interfaces rather than bespoke integrations. And third, learn from industry leaders. There are already front-runner operators and vendors experimenting with AI-driven energy savings, quality of experience, optimization, and new service models. We would encourage you to learn from their roadmap and understand what has delivered value fastest in order to shape a realistic AI RAN strategy for your organization. So these 3 pillars together provide a practical starting point for turning the AI RAN vision into an executable plan. Thank you very much for listening, and I'll hand over to Fatih from Red Hat for his presentation.
All right, that's a great presentation, thank you. My name is Fatih Nar. I'm a chief architect at Red Hat CTO office. It's a brief background about myself as a relevance to this conversation. I started my career at the Nortel Networks as a software engineer for mobile networks. Spent quite some time there and then moved to Ericsson for IP products and product development and services at Ericsson. After which I moved to Verizon as a service provider environment for Verizon Cloud, microservices, distributed microservices deployment. After which I went to Google to, as the cloud era started with the cloudification, hybrid cloud strategies, and so on and so forth. Here I am as part of Red Hat last 5 years, have been heavily working in this data mesh, service mesh, data-driven operations, and now we are here to talk about the AI RAN. Next slide, please. So as presented previously, there is a potential by means of market. There is an interest by means of traction and collaborations and consortiums, and there's innovation happening that has been also supported by the standard bodies. The potential is mainly around, has been and still, how can we utilize our infrastructure better? How can we utilize our spectrum better? How can we avoid the downfalls of outages? That is kind of hinting to lowering the operational expenditure and maybe introducing new services, new features as new revenue channels. As presented, there's a value of ORAN that has been offering this open architecture, disaggregated functions, and that is now AI is coming into this picture with AI RAN, is to make things much smoother, better, by means of higher utilization, by means of better deployment model, by means of distributing the intelligence towards the consumers. And as pointed, there are a lot of interest from not only from the service provider, but also the vendors such as Ericsson, Nokia, and others that has been driving the innovation to deliver 6G better than 5G. That's why the standard bodies have been incorporating AI approaches, AI facilities into their standards that's coming our way for 6G. Next page. All right, what does Red Hat do briefly in this domain is mainly Red Hat is the de facto application platform. Obviously, you remember Red Hat from the operating system perspective as Linux, the dominant enterprise Linux distro, later which grew into the application platform with OpenShift, and throughout the journey, the addition of the Ansible, addition of the advanced cluster security and management for scale, as well as maturity of the operational models. Now we are talking about the Red Hat OpenShift AI, adding AI capabilities on top of our platform to enrich these microservices deployments, enrich these microservices software stack wherever they are residing, rather than yet you have to implement another platform, another software silo, which has been proven that it's a mistake. Do not go in building another platform yet for AI only. Grow and enrich your application platform that has been using for microservices around your network and add AI capabilities where and how it is needed. This is what Red Hat has been doing. Next slide, please. All right. So mainly, why we enrich OpenShift now, adding AI capabilities both for training and inference, say with VLLM, which we're going to talk later a little bit, and also distributing that inference with the LLMD project that is becoming a lot of good traction from Google, NVIDIA, and so on and so forth, mainly accelerating the return of investment of these service providers buying those spectrums, buying those footprints in the field to better utilize these investments and also offer better coverage, bigger coverage across the nation. United States is a big country with many states, and geography is big. There are a lot of challenges by means of mountains, line of sight blockages. The weather itself is another challenge in this domain, radio challenge in this domain for radio. This is AI truly shines to adopt the power based on signal to noise ratio, adjust the spectrum based on the traffic patterns and the consumer movements. So these are where we are collaborating with our strategic partners, including the Ericsson, including Nokia and other accelerators, making the platform ready to be used by radio access network workloads that are infusing AI inside. Not only for inference, but also developing those models and delivering autonomous network promise. Today, we are at the edge of almost moving into step-by-step, gradually to autonomous networks. This is where AI plays a very important role. Next slide, please. All right. So in the name of AI RAN, there are a lot of statements: AI for RAN, AI and RAN, AI on RAN, and AI ops. In summary, this is two sides of the coins. AI for networks, which is AI to be used to deliver the network operations, including access network being a radio, better by means of better utilization, avoiding downfall, or as I repeat, the mean time to detect, mean time to recover, as well as running AI on the networks, using the network as the grid for these intelligence. It can be either sitting on top or next to it, using the underlying infrastructure, whatever available down there. The key factor here, my beloved friends and family, is remember what was the promise of the cloud? Cloud was promising to lower your investment by means of unified hardware layer. What was cloud native software promise? Unified software layer, so you can move your workloads wherever you need it to without worrying, is this application going to work on this platform or in this cloud or on my infrastructure, without these worrying. So this is where cloud platform itself, together with the hardware availability, plays an important role. Next slide, please. All right. Potential use cases for AI RAN. There could be many use cases for AI RAN, for using AI for RAN or running AI on top of RAN or next to the RAN. One of the critical things that we are chasing here, autonomous networks, autonomous radio access network operations. This is where we offer OpenShift capabilities, enriched with the VLLM, enriched with our feature store for data engineering. This is one of the critical factors. One of the key things that telcos say, we have a lot of data by means of sheer size of data. But when you look at telcos, not necessarily able to use that data because that data is such a mess. You have to go dig into what features, what values up there. When you do feature engineering, you have to make sure these feature values are also existing, not necessarily null or empty. So this is where OpenShift plays critical role for data pipelines, model training, model distribution as the AI ops or ML ops pipeline, as we have been doing with the DevSecOps and DevOps paradigm, which we started with delivering applications starting from source code down to the additional features, kind of a pipeline software delivered towards where it needs to run. This is the same approach for AI as well, with AI apps for run. And now we are going with the AI on run edge. NVIDIA has offered this week that the open sourcing the aerial software stack. Thank you, NVIDIA. And we have been heavily collaborating with NVIDIA in this domain. And you will see more use cases and ready-to-use examples of AI run applications coming your way through Red Hat and as well as NVIDIA. And other thing we need to not forget, the classical machine learning, the predictive models, say the intent classification, predicting next failure by means of anomaly detection. These are still classic machine learning, is super critical to maintain those abilities. Telcos have been using AI for quite some time, for revenue assurance, service assurance, so on and so forth. Those gonna stay. Maybe we'll even grow those in different use cases, but complement with generative AI around the issue remediation, path decision logic, plugging into the workflows. So as you're experiencing probably too, the models themselves may not necessarily enough for better accuracy, better satisfaction, where you need to use in-house data sources, in-house knowledge bases to augment your prompts with the better question asking. The question asking is the critical part for AI here. You have to give enough data points, enough clearance, enough structural breakdowns of your questions, so you get better output by means of accuracy. This is where Red Hat offers retrieval augmented generation with the vector DBs, ready-to-use out-of-box, feature store engineering, as well as best inference runtime with VLLM for price performance, with KV caching for quantization. Next slide, please. So summary, too much talking, I apologize. Summary is Red Hat offers existing microservices application platform to renovate and redefine itself in the AI era with introducing AI capabilities with Red Hat OpenShift AI, using following the path of open source with the VLLM, LLMD, and also delivering these services and experience with orchestrated manner with MLOps pipeline. Driving the automation with AIOps for autonomous networks is truly possible with OpenShift AI because we offer these capabilities as a platform for your own premise as well as your hybrid cloud, whoever you are partnering with. We follow the vendor neutral standards with 3GPP, AI RAN, as well as ORAN Alliance. We are partnering them for their interfaces such as O2 and so on and so forth. In coming days, our collaboration will grow, and we will like to grow with you as well. Thank you for your time and listening to me today. I appreciate it.
Hello, I think it's my turn now. My name is Mal Erol Kantarcı. I'm a strategic product manager for AI in RAN at Ericsson. So in my role, I oversee our AI-powered features on 5G NR, AI strategy, and I'm also supporting our teams in AI RAN Alliance. And well, I wear two hats, maybe just a bit on that too, because Fatih did a bit of an introduction. I'm also a professor at University of Ottawa and Canada Research Chair in AI-enabled networks. So it's an exciting time for AI RAN, as Alice was mentioning at the beginning. Now we are seeing AI from research moving into products. And I think being a product manager at this time is really, really exciting. But then let me tell you a bit about what do we do at Ericsson. Why do we do? Maybe we start with why do we do things, right? We do a deeper dive on AI RAN and talk about how we create value and unlock new business opportunities for CSPs while being future ready. So next slide, please. So I want to start with our vision. Basically, the why of things, right? So our vision is to build high-performing programmable networks that will enable CSPs to address new business opportunities, basically for their business growth. And we want them to progress in their journey for autonomous networks. And when we think about this, there are certain pillars that these two fundamental paradigms stand on. And what are they? One, advanced silicon, two, AI, and the third pillar is openness. And we bring these two paradigms actually into realizations. For the business side of things, we talk about differentiated connectivity and network APIs. What does it mean? So basically, with programmability, we have new services, new applications that can benefit from differentiated connectivity. And you can think about differentiated connectivity as such. One user needs maybe more throughput, the other one needs low latency, the other user needs something else. So the network, one network, being able to provide, to be multi-purpose and to provide multiple connectivity levels. And AI is a good way to realize that. And then, of course, we have network APIs on the top to allow more applications, more control. But then the AI comes into the picture in multiple ways. And one of the ways is that actually the use of AI in the devices. So as these devices like smart glasses, XR, VR glasses increase, we will see new AI applications being unlocked and CSPs monetizing these opportunities. So that's why we say it's a new business paradigm, right? But then on the other side, there's an equally important paradigm, which is the operational aspect of the network. We should not forget that, because that's very critical, right? So in that domain, actually, we talk about autonomous networks. Why we talk about this is because networks are becoming multi-purpose, basically, and we want that multi-purpose to be agile. So in a complex system, you want agility. What you do is you use AI to make it smarter, intelligent, you remove the manual operations, and you make it basically autonomous. So that's what we are aiming to achieve, to have CSPs on their journeys to create value. But if you go to the next slide, there's one thing that I like talking about a lot, and it's the intents, right? So if we start from the intents, this is a very key concept, right? It's a revolutionary concept. So it will enable the CSPs to define what they want to do rather than how they want to do it. Now, this seems very simple, but those of us who have been in this world, telco business for long, know that this is a very important thing. So with this, what happens is CSPs can focus on their business goals. It could be maximizing throughput or lowering latency in a certain geographical location, right? Say there's a Taylor Swift concert. I like giving this example. Kids love it. So say there's a Taylor Swift concert somewhere and the operator needs to create slices and quickly provide service and configure the network. Normally, this configuration would take quite long, but with Intense, then it becomes really agile. And there could be another thing happening at the same time within the same geographical region, then it's much easier to spin off basically multiple services for connectivity at this time. So that's where, you know, the autonomous comes into the RAN architecture. But then if we think about the RAN architecture, now it's also very important to have a flexible architecture, right? Because we will realize Intense with AI, then we have to make sure AI is used where it makes sense. When we say this, what we mean is we talk about two layers, right? On the right-hand side of the slide, actually, you see Intense coming from the top, and they are first faced with RAPs, which is at the top level. RAPs sit on the SMO. And SMO is an implementation of non-real-time RIC for ORAN. And then at the bottom, if you go one layer down, there is the 5G RAN, which is the 5G composed of 5G advanced software and 5G RAN software that runs on one of the many compute platforms. And then at the bottom, you have the radio network. The bottom part of the picture is distributed, thousands of base stations, cell sites that we are talking about. So that makes it very critical to determine which functionality or AI will be used in which functionality and how it will be used. So the top we call centralized automation, the bottom we call as distributed automation. Now, if we talk about, first of all, the top part, the RAPs, right? I want to double click on this a little bit because I think that's a very important and relevant area where Ericsson contributes a lot to the openness. We have been the #1 contributor to the ORAN community with more than 18% contributions, code software contributions. We have in our RAP ecosystem, we have more than 80 partners. This is a huge number if you think about it. And as of now, and increasing day by day, more than 110 RAPs already developed. It's a big, thousands of people developer community. And AI is one of the fundamental technologies used there. If we go a little bit to the bottom and we make sure that we are OPEX efficient, etc. At the bottom, of course, we talk about now the ROI part of things, return on investments, and that's very important because we need to make AI cost efficient, energy efficient, and we need to make sure that the investments already in place can be utilized. So how do we do that? I will get to that with some real world examples. But before I do that, there's another aspect of openness, which is, of course, the open architecture and the growing ecosystem within the ORAN. Now, that brings me to the next slide, actually. So within the openness, actually, we have our software, RAN software, that's portable over multiple vendor platforms. So that is really important because that kind of allows the CSPs choose best of breed, which was one of the slogans, or maybe still the slogans of ORAN, right? So basically, our portable software allows CSPs to leverage their platform of choice, which platform they choose, without a lock-in. So we work with hardware vendors like Intel, AMD, ARM, NVIDIA, and they make sure we can have software that can run on both our cost and energy efficient, of course, RAN compute, our own silicon, and also the COTS hardware. Again, within this ecosystem, of course, we collaborate with Red Hat at the CAS layer. I think we have been very good partners from the get-go. And this whole vision is all aligned with the ORAN hardware-software disaggregation. So this portability and disaggregation are actually hand-in-hand concepts. And when we think about it, I mean, the purpose of a portable software is to have RAN functionality. We call them as RAN features, but sometimes they are called as RAN use cases or RAN functions. So I might use them interchangeably. The idea is to implement these RAN features across all hardware, possible hardware or choice of CSP. Now, within the AI RAN ecosystem, of course, this interest grows. The ecosystem grows. And I mean, I'm always very proud to say that Ericsson is an executive member of the AI RAN Alliance. So we were one of the founding members of the alliance when it was initiated in 2024. And we have a chair position at the technical steering committee, again, chairs, vice chairs in work groups. And there is hard work actually going in that alliance, thanks to many collaborators and contributors. Then on the other hand, we have a telecom infra projects Telco AI group, which looks at the regulatory aspects. And this is also a very important aspect, right? So basically our presence defines what the future of AI RAN will be by taking aspects, both the use cases, architectures in the AI RAN Alliance, and also the technology, economics, and policy perspectives in various groups. But then, moving on, I mean, if I think about it, what really makes Ericsson leader in this area is our capability to test the features, real features in real operator environments. And I think that has been also personally something that strikes me the most because, you know, coming from a research background, moving into development, you see things working in live networks is quite exciting. And maybe we can go to the next slide. Now I'll tell you a bit about like how we do things, right? We have a large global deployed base, and this has allowed us to gain learnings. And we have done this in LTE. Maybe I should mention this first, right? We have features with AI developed already in LTE. They are widely deployed in operator networks. They turn on a switch and activate the feature basically, and then we see gains there. And this is one thing, of course, seeing the gains, but of course the learnings that we get from LTE is very important when we drive the features in the NR area. So in this slide particularly, I'm focusing on one feature, which is one of our favorite ones, AI native link adaptation. We have done trials with Bell Canada, and we have shown that we could reach up to 20% downlink throughput increase and also up to 10% spectral efficiency increase. And these are like huge numbers because we do the comparisons to our Ericsson baselines. So these are like, if you think about it, you already have a high performing network, proven benchmarks, etc. And then on top of it, you make the performance increase, and that's kind of a really good gain. So maybe very briefly, and I don't want to take more time than I should. So this feature learns the environment that is deployed in, basically the channel conditions, and then it adjusts its parameters accordingly. And that's why it's so successful. But how we see it that, so we've been doing features in LTE, we are now doing features in 5G, but the most important thing is this is going to drive more functionalities in 6G. So we are now setting the building blocks for 6G. Of course, I mean, when we talk about these things, telco AI models are very important. So, I mean, they have to be very efficient because we have very tight timelines when it comes to the RAN software. Maybe for the top layer RFs, it's not the case. But when we talk about the real-time software that we have in the RAN stack, latency is very, very critical. A lot of these use cases that we think about run in the critical loop, so they have microsecond level latency requirements. So whatever AI model that we have, that needs to run very, very fast, efficient, and energy efficient at the same time. But I mean, in a nutshell, I think what I can say is we see the real gains from AI in the field with real features, and we see that there is room for improvement. And what we will do is, our vision is that we will build onto our foundations in 5G and move to 6G with solid findings and foundations. Thank you.
Great, thanks, Mel. That was really good. So on to our panel discussion. But yeah, thank you, Mel. Thank you, Fatih. Thank you, Alice, as well, for your presentations. I think all of that kind of gave us a really good foundation for the discussion that we're about to have. So I guess let's dive straight in. I think AI RAN is generating a lot of excitement and is talked a lot in the industry. However, I think that sometimes it can feel a little bit conceptual, and many people in the industry, and actually in our previous webinars as well, have been asking us, where is it actually working today? So I guess to anchor this panel discussion, I would like to talk a bit about the real deployment. So just to look a little bit about the genuine progress and how it looks like on the ground. And so my question is, what are some of the most compelling real world examples of AI RAN success so far? And how about we start with you, Kanika, on this one? And you could also do a quick introduction to your role before you get into the details, because I know other panelists have had the chance to do that before presenting.
Thank you very much, Gabby, for having me on. My name is Kanika, and I'm part of the NVIDIA telecom team. We're a very small team. I take care of everything marketing, everything building the narrative. The best part, I think, of my job is a front row seat to seeing the massive AI adoption that's happening by telcos, by the ecosystem across the board. So not just AI RAN and 6G, but I look at how they are building AI infrastructure, how they are adopting agentic AI to drive autonomous networks, and so on. So with that, let me get back to your question and some real world examples. We're thrilled. Actually, this year was a momentous one where AI RAN as a technology, moved on from just proving the merits of the technology, validating, to really a big step towards commercialization. And let me give you a few highlights from the year that talk about that momentum. I hope you all saw the big story that we announced at NVIDIA's GTC event, which was our own platform called NVIDIA Arc Pro, which is really a small 2U size kind of form factor, fits beautifully into an existing base station. And the second part of it was our great partnership with Nokia. They already have millions of AirScale base stations deployed, and this Arc Pro kind of slides into those base stations. That's a real world example of moving towards commercialization, that telcos can actually upgrade their existing platforms coming soon. So I'm absolutely excited for what's ahead. You will hear obviously great progress that we're making together with telcos around the world on adoption of AI RAN. Of course, with T-Mobile, we made great progress. We've taken AI RAN from the lab to now, out some field trials. SoftBank is, again, a big champion. They've been leading ahead of the pack. In fact, they built iTrust, which was, using the entire AI RAN architecture, and we are proud to contribute to NVIDIA's Aerial software, which, as Fatih mentioned, is open source now, and the whole world can build on it. So SoftBank has made some really fantastic progress. Recently, they announced massive MIMO 64TR, which again amplifies the benefits of using AI for radio signal processing itself. Another key example that we are proud to talk about is, our work with the American 6G ecosystem, where we built a fully AI native stack from the ground up in less than 6 months, partnering with companies like ODC, the ORAN development company. They built the entire CU, DU, the entire vRAN layer, again, reusing bits and pieces of NVIDIA's Aerial software. And Cisco brought in their UPF security, the packet core pieces. We had Booz Allen and MITRE write applications like ISAP, like spectrum sensing. And again, all of these are AI native applications, right? In the way they sense the spectrum, in the way they mitigate that, in the way they actually move the channel without like kind of blocking the whole channel the moment you see, interference from sort of a radar or something, right? So these are concrete examples. Next year we'll follow on all those beats. I'm really thrilled with the progress, and of course, AI RAN Alliance, we're proud to be part of the Alliance as a founding member. I'm myself a part of the steering committee there. And again, I get to see the amazing progress that's been made through the work groups, AI for RAN, AI on RAN. So to me, that's the highlights. That's a great proof points of how we are moving forward.
Brilliant. I mean, I think it's always really good to hear about some proof points and what some of the industry leaders are doing in the space and kind of learn from them and then kind of apply that to your own roadmap. So it's really interesting to hear that. And I'm really glad that you mentioned your work with T-Mobile and SoftBank as well, because there's actually a really good question related to this from the audience, which was around how is AI RAN helping telcos specifically with monetization? What sort of AI use cases are being delivered for their enterprise customers, and I guess how is the adoption at the moment looking like by the telcos? And I was thinking maybe Melika, we could start with you on that one. Do you have a perspective on this?
Absolutely, and I can tell you there is a great interest from our global base, a large global base of customers. Of course, I mean, AI is one of the hottest topics. They want to try out things, they want to play with it, they want to tune the knobs. And we have many trials ongoing around the globe with North American operators, Asian operators, European operators, and also operators in Australia. So I think a lot of progress has been done in that sense. And I mean, as I mentioned, link adaptation is one of our NR features, but we also had features in LTE, so they always have a chance to see, observe the gains in even in the older days, I would say. But then, I mean, it's not only the features, right? We also have RFs that the operators are showing great interest, our automation tools. And within the RFs, actually, we recently basically published some of our RFs and their, especially network optimizer RFs that use AI. And again, with Asian operators, for instance, we have seen gains like 30% uplink throughput increase, and also increase in or reduction in call drop rates, basically a more efficient use of the network. But I can tell you, I mean, the interest is there, and the development is there to meet the demand. I think we are at a peak time for this area.
Perfect. No, that's really good to hear. And I saw, Fatih, you were nodding along when Mel was speaking. Do you have anything to add, or do you share the same opinion?
Well, I like to keep ourselves honest a little bit here. Most of the successes are controlled pilots. Like say this link adaptation, and maybe Melke can correct me, 10% increase over comparison to control group and proving the value is not necessarily large scale production yet. And others as well, Rakuten's anomaly detection, Vodafone's energy optimization trials, Dish's traffic prediction experiments are all controlled pilots, and hopefully it will hit to the production. But on the side, I think the clearest win in AI RAN is the energy management and energy optimization, 10 to 15% power savings demonstrated in multiple trials. We have through our customers as partners, and that is hinting into AI-assisted self-planning, reducing driving the test cost, and so on and so forth. It is energy savings are the biggest things, in my humble opinion, in radio access network as a success factor, because radio consumes a lot of energy. And if you and by means of scale too, if you're able to even improve tiny bit of energy saving per radio station, it accumulates to significant numbers. From Red Hat perspective, using OpenShift deployments with tier 1 operators, showing distributed AI inference at the edge is today what we are offering. The success stories needs to be a little bit qualification on scale and production readiness as a bottom line.
No, I think you're absolutely right, that a lot of the current progress is in pilot. So I was kind of wondering, if there is anything that could be done to help those telcos move along and, into those commercial deployments, because I think realistically, as technology kind of gains momentum, and especially the way AI RAN kind of gained momentum, quite often it feels like that narrative around it grows faster than the actual deployment reality. And I feel like with AI RAN, there's definitely quite a few misconceptions circulating around that are making telcos a little bit more hesitant to adopt this and kind of slowing the industry down a little bit. So I guess my question is, what do you think are the biggest AI RAN myths that kind of need to be debunked for the industry to move forward? And again, maybe we can start with you, Kanika.
Yeah, I'd love to take that question. NVIDIA has, of course, been pioneering this concept for many years. It seems to have gained attention probably in the recent years, but we've been putting our heads down since the last 7 years and working hard on this. In fact, the work and the intellectual property we created through Aerial, we want to share it with the whole world because we believe it is at a place where now everyone can build on it, right? So we've been at it for a very long time. And two things that, people keep coming and asking me again and again, and they talk about, the economics of leveraging accelerated computing, aka GPUs, and the power consumption. I want to debunk that for everybody. First of all, we would not be doing this if we cannot meet the baseline stringent requirements for telcos radio rollouts. And what are those? That have to meet the cost and power envelope that is available on sites. Cost envelope such that they can distribute it into millions. Power envelope that's limited by what's on this. It is a starting point. It is a baseline requirement. If you cannot meet, the cost and power envelope, and then show the perf gains, there is no point of us doing all of this, right? So that is a starting principles. And I'm proud to say that the work that the team's been doing in the last sort of 7 years, we now managed to kind of deliver dollar per perf and performance per watt comparable to traditional ASICs. And now the journey is really, what do you do more with it? As you get to higher and higher layers of MIMO and much, much more complex, site-based learning, that's where the gains begin to show. And that's where the dollar per perf, the perf per watt, all of that, begins to outpace what you could do with the traditional, ASICs. And GPUs, by the way, for those who may not realize that they're not just the big machines, right, that run for training. We have a tiny, tiny GPU all the way to, small, medium, large, the entire t-shirt sizes. And cost-wise also, the smallest is a couple of hundred to, maybe the 100,000 ones, which are the massive clusters. It doesn't mean you throw all of them at the RAN problem, right? So it starts with this idea of, optimizing performance and cost for the workload. So everything that we build is based on workloads. Arc Pro is a great example, under 300 watts, 2U, very tiny form factor. It runs, 1 petaflops of compute, and it runs all kinds of 5G capability sets. And we've published a lot of numbers, not just us. Our partners have used and published numbers. So I really want to tell people that get out of that mindset. The mindset has to be, this is a baseline, cost, performance, power is a baseline, and what else can we do with it? That's where the conversation needs to go.
Well, that's fascinating. I'm sure it's going to be helpful to a lot of our listeners. What about you, Fatih? Any additional myths that you would like to debunk?
Yeah, so this is why I jumped to this question, because I have been facing daily, I think last 12 months, about a lot of myths in the field. One is, I want to start with one of the Kanika's example. So people come and say, do I need a purpose-built AI infrastructure for AI RAN? We say, no, cloud native platform that you have already can run AI inference alongside the radio access network and other workloads. What you need is to look at that workload and AI requirements, maybe plug in a PCIe based GPU or an accelerator. As Kanika was saying, they have L40, L40S, now they have DGX Spark, which can be plugged into these platforms easily rather than build yet another platform. Build yet another application play is a big mistake. The second one is, as I was kind of hinting in my presentation, around the data. More data, better AI. Well, my friend, not necessarily, especially in telco. Feature engineering, data quality matter more than data volume itself. Telcos have been drowning in data. So it's all about what data you can use for what purposes. For radio access network, control and collect this data, say through open telemetry at the edge, and consume at the edge by means of knowing the domains itself. And this other one is obviously coming, oh, AI will automate the radio access network autonomously soon. Seriously, how soon? Look what has been happened this year with AWS, big outages. AWS, Google even cannot do fully autonomous network. These are gigantic infrastructures with thousands of people, thousands of data scientists. Even they cannot do fully autonomous network. You think more complicated access networks such as radio, subject to inference, subject to weather, and other hurdles, not likely fully be autonomous, but humans were going to be in the loop, in the control for quite some time. The last one is maybe the most important one. It's all about people, process, and technology. It's like a PPT, right? People, process, technology. People say, oh, since I'm going to build the AI Center of Excellence organization. Please don't do it. Please do not segregate your AI and data scientists from the domain expert. They have to be together. Best approach is growing your AI, applied AI knowledge within your existing radio access network operations team. Grow their knowledge with augmenting additional people into the team or additional toolboxes into those teams. So this is where success is happening as well as the failures. And this week we published an article on LFN about don't do center of excellence, do community of practice for AI is where we are hinting as a discipline for cloud native operations, augmenting AI in it for the sake of AI run. People, process, technology. Thank you.
Perfect. That is definitely very catchy. And I'm a bit conscious of time, so I don't want to open another question, another can of worms. So I just wanted to check in, Mel. Do you have anything to add on this one?
Yeah, absolutely. And I mean, I've been thinking for a long time that we have some confusion even in the basic terminology, because I think after 2022, when LLMs came out, there was a lot of buzz around it. So oftentimes AI is associated with very large models from that world. We know that it's a breakthrough, of course, but telco AI models are quite different. So probably that's one of the myths that I would like to debunk, right? So we need large models to understand the language, but then we also need telecom models or telco AI models, as we call them, to understand the language of the wireless environment, RF conditions and propagation characteristics. So with that, actually, I mean, the way to develop them, in our opinion, is that to use domain expertise, and also to have a flexible architecture. And I want to stop for a minute in the flexible architecture because I think this is very important. So in the RAN domain, we are operating very close to real time. So over there, it's really important to be latency efficient. And of course, if you think about the deployment of scale of things at millions of sites, then that's really an equation of TCO. You have to be cost efficient, energy efficient, and you also need to be able to support the capacity that is needed by hundreds of users. Those are the economics of the things rather than just the technology side of things. Then when it comes to, of course, the ability to scale, I think like good examples from the field, like our MIMO feature, which showed 14% improvement that is running in live networks, is a good example. But of course, I mean, not every project, maybe that's one of the myths too that needs to be debunked. Not every project or POC becomes a reality. So we need to make sure that out of these hundreds of thousands of ideas, some of them can be realized in the networks. And I think in the LTE, like that, the example that I gave, MIMO sleep mode was an LTE features we had with 14% improvements. That was a good example of how things are deployed. And AI native link adaptation is going with larger clusters, larger trials. So that's also upcoming as a good example. But I think more and more as the industry matures, with the ecosystem grows, we will see many more examples. And it's really exciting that we can build that trust from the beginning. We can have the economics and the technology in place to realize things.
That is fascinating. And honestly, I would love to keep on discussing this for another hour if we could, but unfortunately, that's all the time we have for today. So thank you again to our panelists, Fatih, Mel, Kanika, for joining us and for sharing your expertise. And also thank you to Alice for your excellent presentation earlier. And of course, thank you to all of you for turning up and contributing with your questions. So as a quick reminder, we'll be sending out the recording of today's session, a copy of the slides, and also the Q&A document with the questions that we didn't get a chance to get to. And there are a couple. So hope you found the session useful and have a great rest of your day. And we hope to see you at our next webinar.
Thank you, Gabby.
For having us.
Thank you. Bye.
Thank you all.